Hello everybody, this is the first video of a series of videos that I am planning to post uh, in the subject chemistry and related subjects. Okay, so the first video that is about significant figures, also abbreviated as SF. Now significant figure uh, appears when they're measured quantities. That means these quantities have some inherent errors and reflects the amount of accuracy in the number in our measurement. So measured quantities. Now, if their exact number counts, then they would not have any errors. Okay, we say they're infinitely uh, exact. Now, let's take an example here. For instance, if you're measuring something, okay, mass, and the mass comes out to be 1.0 grams or 1.05 grams, uh, or 1.000 grams. In each cases, we can see the accuracy of a reading is increasing with the increasing number of digits that are appearing. So when you're measuring something, uh, like in the first 1.0 grams, so you can see the numbers can fluctuate, and this can be, uh, you know, uh, this can have an error of 0.1 gram in the measurement. In the next case, it is plus minus 0.01 grams and plus minus 0.001 grams. So basically, we are getting more and more accurate in our numbers. Now, when there are non-zero numbers, we know that they are there because they are significant, but ambiguities appear when there are zeros. So let's write it down in the proper way. So the rules. So the first rule is that the non-zero numbers. So non-zero numbers, they are always significant. Okay. So if you have example like uh, 1 2 3 4 or 1 2 5 4, that has four significant figure. So as I said, the ambiguity appears when there are zeros, and there are three kind of zeros that we usually come across. The first one is the uh, leading zeros. So these zeros appear at the beginning of number. They are not significant. So example can be 0.0024, and that would be equal to two significant figure. The next class of zeros are the captivating zeros. So captivating zeros, they appear in between two non-zero numbers, and they are always significant. Okay. The third group of zeros that we see are the trailing zeros. So the trailing zeros, they are significant only, and this is important, only in presence of decimal point. So that means if I have a number 3600, okay, so this is the last significant figure, and the total number of significant figure is 2SF. Now, because the last significant figure is at the 100th place, it can carry an error of plus minus 100. So this number can be 3700 or it can be 3500. Now, if somebody wants to say that, well, they are accurate to the last digit, that means the last zero, and the way to depict that would be put a decimal point at the end. So with this, we can say that this has four significant figure with a plus minus error of 1. And if we have 3600.0, that would be 5 significant figure. Now, another way of writing numbers, and that is what we call the scientific notation. The scientific notation, an example of scientific notation can be uh, like 1.28 10 to the power 5. So it's in the exponent form, and we say that the form is of the type m multiplied by 10 to the power n. The m is the real part, which can be between 1 and 10. So including 1 but not including 10, and n is integer, plus minus integer. Okay, so when numbers written in this form, it is the m, so m determines the number of significant figure. So that means in our example here, so this would be 3 significant figure. Now, scientific notation is a very convenient way of writing numbers in whatever number of significant figures you want, and we'll discuss that later. But let's discuss another important thing: how to determine significant figure in measurement. Now, when you are measuring something, let's say you are measuring the length of a stick with a ruler, how many significant figure should I keep? How many decimal points should be there? And that depends on the accuracy of the instrument. Let's say that I'm trying to measure the stick here with a ruler. So this is 4, this is 5, and 6, and this is in centimeter. Now, if you look at it, I am certain that this is 4 centimeter plus something. Okay, so significant figure basically constitute of the certain number and my I estimate. So when you think of significant figure, this is the certain number. So that comes from the instrument that I'm using and my I estimate, which can also be the fluctuating number. So together they form a scientific, together they form a significant figure. So here I can say that it is probably 4.5 centimeter. Now, if I take a different ruler, okay, there are 10 divisions in between, then I can say that, okay, I am certain about 4.4 and there is little bit extra here, and I can say that this is 4.4 plus something, this many centimeter, and probably 4.45 centimeter. So in this second uh, measurement, my error can be 0.01 centimeter, while in the previous case this was 0.1 centimeter. So greater the number of significant figure, greater is my accuracy. Now I'm certain about the 4.4. Earlier I was not even certain about the 4.5. So greater significant figure means greater accuracy. Now we can take another example here, like measuring water in a cylinder. So let's say that we have a cylinder, okay, containing water, and this is 40 and this 50, and in between there are 10 divisions, something like this. And let's say the water is somewhere here, and whenever you are measuring something liquid, you place your eyes right exactly at the lower meniscus, and these are in milliliter. Okay, so I can certainly read 46 milliliter, and then I make my I estimate, which is a 0. So the total number of sig fig that I come from this reading is 3 significant figure with 1 decimal place of accuracy. Now, if you take a burette, so this is a burette, and let's say that this is 40 and this is 41, and there are 10 divisions in between, and the water is somewhere here. Okay, so this is the water. So if you place an eye here and measure it, okay, then I can certainly say that this is 40.6 with certainty, and then I make my estimate. Okay, so making it 40.60, so that is 4 significant figure with 2 decimal place. So that means this burette is more accurate than the cylinder. So we can basically, when you choose an instrument for measurement, we have to understand the level of accuracy that is present in that instrument, which is a very practical way of doing our science. So in the next video, we are going to look at algebraic operations involving significant figures. Okay, so see you next time. Please like this video and subscribe to our channel. Thank you very much.